All right, so chapter 4 is about transport layer. So if you recall previous lessons, there are in the OSI model there are 7 layers, and one of the layer is transport layer that plays very important part in network communication. Okay, so let's see what does transport layer do. Okay, so in this module you will learn about the data transportation. We're going to overview the TCP/IP characteristic, which is important. Sorry, TCP characteristic. TCP is one of the protocol of TCP/IP suite of protocol. Okay, so the TCP is actually responsible for transporting packets over the network. Then you have another protocol called UDP. Okay, we'll also discuss port numbers, which are very important for troubleshooting or for securing the network. Okay, and also reliability and UDP communication. Okay, so so the transportation of data. So data is need to be transported from one node to another node, from one host to another host. Okay, so as you guys already know, the data is in the form of packets, and these packets are transmitted from source to the destination, and the protocol that is responsible for, or the layer, sorry, the layer that is responsible for transporting those packets is the transport layer. Okay, so it's responsible for logical communications between applications. Logical communication means software. Okay, and it also provide link between application layer and the lower layer. So if you see it, it sits between application and the internet layer. So one of the job of the transport layer is provide the link between those two layers. Okay, and let's see. So what are the responsibilities of the transport layer? Well, obviously, it transports packets from source to destination, and while it's transporting packets between hosts, it tracks individual conversation. Okay, so it tracks every conversation. So in case there's an error, okay, between while the data is being transferred, it segments data and reassemble segments. So it break data into smaller segments from the source, and at the destination it reassembles them, because when the data is broken down into smaller segments, they're easier to transport, or they're easier to carry. It also adds header information. We'll talk about what is the later, what is the header, what type of information is in the header. Because you could have multiple conversations on the network. So what it does, so what data link layer, what transport layer does is it identify, separate, and manage those multiple conversations. So you can see it provides very important service, and it uses segmentation and multiplexing uh, for different conversation to take place. Okay. Okay. So transport layer, as you know, is the standard, and then there are services or protocol that uses the transport layer or work with the transport layer. Okay, and these protocols are, so there are two protocols that uses the transport layer. Therefore, they're the protocol these protocol actually responsible for transporting data. And these protocol are the TCP and UDP, okay? So in that protocol, in the TCP/IP suite of protocol, you have protocols with specific responsibilities, okay, and then they work with a specific layer of the TCP/IP or the internet model, okay. So the protocol that uses the transport layer are the TCP and UDP, and these protocols are responsible for transferring message between hosts. So let's talk about the TCP. So there are two protocols for transporting data, TCP and UDP, and they both have different characteristics. Okay. So what are the characteristic of TCP protocol? First of all, it's a reliable. It provides reliability and flow control. Okay, meaning it's a reliable protocol. How it's so the conversation over TCP/IP is reliable, and how it provides reliability by by numbering and track data segments. So each segments that it creates, it numbers it and then it tracks them. Okay. It also acknowledge received data. So when the data is received using TCP/IP, TCP protocol, let's say from this user to the server, TCP acknowledges that the data is received. It sends the acknowledgement to the sender that data has been received. So that's why it provides reliability. Okay, that's how it's provide reliability, by acknowledging it. And if the data is lost, if one segment is lost in between, it retransmits the acknowledgement, okay, after a certain amount of time. So that's how. So the main thing you need to know is that the TCP is a reliable protocol, and these are the steps it takes to ensure reliability. It also uses sequence number or data that arrived in wrong order. So because of the sequence numbers, if the data arrives in wrong order, TCP knows it. Okay, because data that arrives in wrong order cannot be probably will not reach its destination. And one of the thing that TCP does is it controls the rate of data is being sent from source to the destination. For example, you have different bandwidth on the internet. There are 100 megabits per second connection, there are 1 gigabit per second connection, and then there are 10 megabits per second connection. So what TCP/IP does is it controls the rate of data that is acceptable by both senders and the receiver. Okay, so all these steps it takes to ensure reliability. Then you have other protocols for transportation. So one is TCP and the other one is UDP. It's called User Datagram Protocol. It also responsible for delivering packets from source to destination. It's very fast. It has less overhead, but this speed comes with the cost. It's not reliable, meaning, and also there's other term is being used to describe UDP is connectionless. It's a connectionless protocol, meaning it does not provide any reliability. It does not do all of the things that the TCP does. It does not send acknowledgement if the data is not received properly. Okay, It does not use the sequence number, so it's less reliable, but it's faster. If you see, TCP takes a lot of steps, number of steps to ensure reliability. These steps takes time. Okay. So therefore, but user datagram, since it's not reliable, it's faster. Okay, because it has to perform less steps. In computing, anything that is more reliable is actually slower. Okay, so you have to choose which one is more suitable for a specific task and or for specific functions. Okay. Okay, so which protocol is better? UDP, which is faster but less reliable, or TCP is little slower but reliable? Okay, as a network engineer, you don't get to choose which protocol to use on your network. It is dictated by services and applications. Okay, for some applications, UDP is more suitable. For example, voice over IP, telephone conversation. For DNS, they does not require the acknowledgement sent to the sender. So these services uses UDP, meaning they're embedded. And then there are services that requires reliability to function. And those services such as SMTP, the mail protocol, or HTTP or HTTPS, these World Wide Web protocol that you guys are aware of. Okay. So again, one is not better than the other. It depends on the situation, okay, or the services. Which one is better protocol for specific services? Now, as I said, it's not us, network engineer or network support people, to decide which protocol to use. So why do we need to have a knowledge of these protocols? Again, is the same thing for troubleshooting, network monitoring, okay, and to improve network performance. So when you're monitoring your network, you see a lot of UDP packets that are not supposed to be there. So that means there's either a malfunctioning software, or there might be, or your system is compromised. Okay. So for that reason, you have to monitor the activity on your network, like what protocols are being used. So these are the TCP features. Okay, it establishes a session. Since it's a connection-oriented protocol, okay, so it negotiates and establishes a permanent connection between source and destination. So that's the one thing it does. That's the characteristics of TCP. TCP, it ensures reliable delivery. So that's what it does. It ensures that each segment is sent by the source arrive at the destination. Okay, it's not. It does not. It's not lost in between. And it also provides same order delivery, because network may provide multiple routes. As you know, you have multiple routes and have different transmission rates, so the data can arrive. So data can arrive. So it makes sure that data is not arrive in the wrong order. Okay. And it also responsible for to controlling the flow of conversation. Okay. So the network host, as you know, each host has its own set of resources. Okay, they have limited memory and processing power. So when TCP, so the TCP is aware that these resources should not be overwhelmed or overtaxed. So it can request that the sending application reduce the rate of data flow. Okay, so one sending application is sending the packet too fast that the receiver can handle. Okay, because it has less memory and less processing power. So TCP actually controls that. Okay, this flow of conversation. That's why we on a network we have different type of computers coexist. Slower computer and the faster computer, they can coexist in the same network. So this is the header, TCP header looks like. Okay, as you can see, there are a lot of entries in TCP header. It tracks ports. We'll talk about the ports later. So there's a source port and the destination port, just like there's a source address and the destination address. And as you can see, there are sequence numbers, acknowledgement numbers. There's a window size. We'll talk about the window size a little bit later. And then application layer data itself. Okay, so this is how, and it's total 20 bytes. So this is a typical TCP header look like. Anyway, you guys don't need to remember all these fields. Okay, it's just you have to have an idea what inside the TCP header. All right, so the source port, as you guys already know, 16-bit field, destination port, sequence number, data assembly purposes. It's used for the sequence number, the data assembly purposes. It has acknowledgement number, the length of the header. What is the total length of the header? And then control bits, window size. Okay, what window size does is it indicates the number of bytes that can be accepted at one time. Okay, so window size means the receiver only receives the data that it can handle. So that's how they agree on the size of the data. And it's called window size. All right, so what are the applications? So it's the application that decides what protocol to use. So you have FTP, HTTP, SMTP, and SSH, which is a secure shell. I guess you guys already know what these protocols do. Okay, SSH is the secure socket shell, which is for remote connection that are encrypted, unlike telnet connection. All right, so that was the characteristic of TCP that is part of the TCP/IP protocol. Now the second protocol is UDP. Okay, what are the UDP features? Reconstructed in the order that is received. So it reconstruct the data in the same order as it received. Any segments, any packet that are lost are not resent. So if the packet is lost, that are not going to be resent. Okay, because it does not provide any acknowledgement. It's not a connection. It's a connectionless protocol. Okay, it's not connection-oriented protocol like TCP. For that reason, because it's connectionless, it's not reliable, there's no session establishment, and the sending is not informed about the resource availability. So it sounds terrible compared to TCP. It doesn't do any of this. So it seems like UDP is not very secure, or not very reliable. And if there's no reliability, why use it? Again, some application does not require that level of reliability, but also it's just because this protocol is not providing reliability. That means any application that is using UDP is not reliable. actually reliability is provided by other applications that use UDP. Okay, so if the reliability is needed, that is provided by the application, not by the protocol. Okay, so for that reason, UDP is still used. So if you look at the UDP header, it's much smaller compared to the TCP header because it does not the only reason it's smaller because it does not do all of the things that TCP does. Okay, so it has to perform less. It still has source port and the destination port. Okay, and the length, and it's much smaller. It's 8 bytes. So what is okay? So I'm going to tell you about the source port in the next slide. About the port. Sorry, there is a section about the port. So actually, a port identify a specific application. Okay, IP address only identify a host, the whole computer or the server. The port identify a specific application. For example, either you're accessing FTP, either you're accessing web page, either you're using telnet to connect to the remote server. Okay, so that's why the ports are identify all these services. Okay, so you have a source port and the destination port. Okay, source ports identify where the request coming from, and the destination port identify where the request is being sent, or what application is being requested. Then there's length. Okay, UDP is a 16-bit field, and then there's a checksum for error checking. Okay, so these are the applications that uses UDP. So as you can see, there are a lot more applications using UDP than the TCP. Okay, even though it's not reliable, but actually it's faster. Again, reliability can be provided by application itself. Okay, so DHCP, DNS, SNMP, TFTP. Okay, voice over IP, video conferencing, they all uses UDP protocol. All right, let's talk about the ports. So the ports are, as I said before, so you could have a server that is running web services, that is running email services, also is configured to use SSH in case you want to access this server from remote location. It can run what other? It can also be running DHCP services. Okay. So how the server would identify each services? Because IP address just identified the server. Okay. If somebody is asking for a web page, if somebody is asking for an email, how the server would know that what a user is being requesting. So for that reason, there are port numbers. Okay, think of port as identification of services or applications. Okay, and there are two type of ports. There's a source port and there's a destination port. Because if you're requesting a service, for example, web service, so you request a web page from a server. With the destination port, server knows that you're requesting a web page, okay, because of the port number. Now server has to respond to this request, meaning he has to display that web page to the user. Now there are hundreds of users requesting a web page. How server knows which user to send that web page, or which user is asking for the web page out of those hundreds of users, it identifies, so it responds by looking at the source port. So each source, each host that is requesting a service also has a port number, a source port number, just like they have the source IP address. Okay, so that's the purpose of the port. So there are source ports and their destination port. Okay, so these both source and the destination ports are placed with the segment, and these segments are encapsulated inside the IP packets. Okay, this is the IP packet. Okay, so the combination of the source address and the source port number is known as socket. So it's just the term that is used in network terminology. So if in the exam or whatever, if somebody asks you what is a socket, socket is the combination of both the source IP address and the and source port number. Okay, or the destination IP address and the destination port number. So if you look at the header, you have the MAC address, source IP, destination IP, and then you have the source port number and the destination port number. Okay, in this case, 21 represents, port 21 is used for FTP, file transfer protocol. So you can see the destination port is 21. And web server or HTTP uses port 80. Okay, that is a request for. So this, because of the port numbers, server knows which application is being requested. Okay, and then it responds by using the source port numbers. So this 1305 requested FTP, so it will send an FTP services, or it will provide FTP services to port 1305. Another port 1099 request web services, so it will respond, it will display the web services to 1099 port. That's the reason there's a source port number and the destination port number. This is very, very important to understand when you're securing your network. Okay, because you filter traffic based on ports. Now, port numbers. So there are well-known ports from 0 to 1023. These ports are already reserved for popular services or applications such as web browsers, email clients, and remote access clients. Okay, you cannot use any of these ports for any other purposes. And that's why they're called well-known ports from 0 to 1023. Okay, then you have registered ports from 1024 to 49,151. These numbers are assigned by IANA, which is the organization that assign IP addresses and the port number to any entity or to any organization for a specific process or application. So if you're creating an application that should run on the internet, you have to request a port number that you can use with your application or with your services from IANA. Okay. So, for example, here Cisco has registered port 1812 for its Radius server authentication process. Radius server is a server that provides logging. So Cisco registered this port. So anyway, if one of you who decide one day to create an application that should run on the server, you have to register a port with IANA. Then you have private or dynamic ports. These ports are also known as ephemeral ephemeral ports, okay? And the client operating system usually assigns these ports dynamically, okay? So it's the operating system that assigns these ports, and they are used to identify client application during communication. So you have dynamic ports or the private ports, okay, that are numbered from 49,152 to 65,535. So these are the three type of ports that you need to remember. All right, so let's look at the well-known ports number. If you Google a well-known port number on the internet, you will see all the list of every single port. Obviously, you don't need to memorize all these numbers. You can always Google, you can search whenever you need a specific port number. For example, you don't want anybody to telnet into your network, okay, or access remotely into your network. So you want to block telnet in your network, right? So what you do is most application and routers, right, do that can block a specific service or application by using the port number. So you have to know the port number of telnet, which is 23. Okay, I don't even remember all these port number. Again, if you need it, you can always Google it, and you will know the port number of a specific application. So yeah, so UDP use 68. DHCP use 67, DNS use 53, 25 is mail protocol, and all these. SSH use 22. So this is just a small list of the well-known port numbers. Just an example, okay? There are a lot more. Now, why do you need to know the port number and the state of TCP connection? It's because an unexplained or a connection that is not known can be a security threat. So if you type, maybe you can type in your computer, you go to Windows, DOS prompt, right? And you type netastat, you will see all the established connections, the list of all the established connection with the port numbers. But if you're not connected to anything and you still see established connection, that could mean that you have a Trojan horse installed in your computer, meaning somebody is accessing your computer from the back door, through the back door without knowing you, okay? But this is a very low level utility, netastat, that is embedded in most operating system. But then you have firewalls, and then you have other network monitoring tools that will list all the connections. But this is still very good, okay? So here with this command, you can verify connections on your network. So the process is TCP communication is each application on the server is configured to use a port numbers. An individual server cannot have two services assigned to the same port. So each service have to have their own port number, okay? So any application assigned to a specific port is considered open. All right, so you have open ports. That's why sometime if let's say HTTP port is open, okay, and you're not using HTTP server in your network, or it's just open because you were using HTTP server before, not anymore, what you should do is you should close that port by using firewall. Like in Windows Firewall, you can see there are ports that you can open or close. If you go to your Wi-Fi router inside, you will also see the feature where you can open or close a specific port. So let's say if you want to host a web server in your computer, Okay. Well, these days you don't need to do it because there are many services out there, some of them even free. Okay. Like for example, Google, you can create your own site on using Google site on Google server. My personal my business website is hosted on Google. I used to have my a website 20 years ago, and I used to have my own web server, but I don't, because hosting website was expensive at that time, but I don't do that anymore. Okay. So in that case, you have to open port 80 in your router, because probably by default, or it should, port 80 is closed. All the ports are closed. Okay. So if you're hosting a web server, just for an example, you have to go to your router and allow the traffic using that port. So when the port is open, any incoming client requesting that service will be accepted. Any request, okay, will be accepted. So this is there's a process of how TCP connection is established. So step one, client initiating the request to the server. Okay. Step two. So this is the step one, initiating the request. Step two, server acknowledges the client and requests a server to client and communication session. Okay. So it sends back acknowledgement to the client, and then client in response establish a connection, okay, with the server. So there are 3 steps, okay, that are used when the connection is established between. So function of the three, so this is called three-way handshake. So it establishes the connection, present the network first, first handshake, second handshake, and the third handshake. Okay. So that's how TCP provide reliability on the network. There's a video in the curriculum that I encourage you to watch. I'm not gonna play it here during the course. This is so if you want to understand more about the three-way handshake, go watch this video. Okay, three-way handshake. So reliability and flow control, because TCP provide reliability and also the flow control. Okay, so how does it do that? So it can, so there may be times when segments do not arrive at their destination or arrive out of order. So all the data must be received in this segment must be reassembled in original order, because if that's how it provides the reliability, and therefore the sequence number are assigned in the header of each packet. So the sequence number are assigned. Every packet has a sequence number, segment 1, 2, 3, 4, 5, 6. And here's the same thing. So they are received. So if for some reason this packet is distorted, okay, and they arrive in a different order, it reassembles. Anyway, sequence number and acknowledgements, there's a video again, okay, that you can watch this video to learn more about sequence number and acknowledgement. It's inside the curriculum. So data can loss frequently, no matter how you design your network. So TCP provides the method of managing these losses. Okay. Among these is a mechanism to transmit segments to acknowledge data. So you see segment 1, acknowledgement, segment 2, segment 3, segment 4. So that's what data loss and retransmission occurs on the network. So again, there's a video about data loss and retransmission that you can watch and learn. Okay. Remember we talked about the window size. Okay, the window size is sender and receiver both has to be agreed on the amount of data that can be transferred. Okay, so flow and it is done by the flow control. Okay, so so the TCP, what it does, it adjusts the rate of data flow between sender and the receiver. Okay, so if sender is sending faster that the receiver can receive, it adjusts it. Okay, the flow of communication. And this is called window size. They agreed on the size of data or the window. It has nothing to do with the Microsoft window, okay? So the maximum, or MSS, is the maximum amount of data that can that the destination device can receive. So that's the maximum segment data that the destination. So they agreed on the maximum amount of data that the destination can receive. So if the sender is sending more data, it has to be reduced to the size of the data that the destination can receive. So congestion is bad on the network. That one of the job of the network professional is to make sure there's no congestion on the network. And one of the because they can overload router and even servers. Okay, to avoid and control congestion, TCP uses several congestion handling mechanism, and it also uses timers and algorithms, okay, to avoid congestion. Now, UDP, these are so in a UDP network, you have data, you have IP phone, okay. UDP provides low overhead and the faster transmission, okay, compared to TCP. And there's no network management, but it's faster because of this small datagram. And UDP does not establish connection before sending data. That's why it's called connectionless protocol. Okay, and it does not track sequence. Okay, UDP has no way to reorder datagram if it's out of order. It just simply reassembles the data in the order that it receives. So it does not, if the data is lost, it does not reassemble, it cannot correct the sequence because it doesn't use any sequence numbers. Okay. So there are applications are known. There are known applications that uses UDP. One of them is FTP server. Okay. Sorry, not FTP server. FTP uses TCP. There's a variation of FTP server. It's called Tftp, Trivial Transfer Protocol. Now, the difference between these two protocols, they both are used to transfer file over the network. One is one uses TCP and the other use Tftp. Okay. So this is the UDP client processes. There's no acknowledgement, just simply client one request a service and the using the source, the source port and the destination port, right? And just UDP send fulfill the request. Now, if there's any data loss in between, either it's corrected by the application itself. Okay. All right, so that is end of module 14. As I said, there are some packet tracer activities in this module that you should do, and watch the videos. Go over the chapter, and there are 3 videos that explains more about both TCP process and the UDP process. And yeah, that's it.